Professor Dave and Chegg here. We know about elimination reactions like E1 and E2, but there is more to discuss in terms of multiple possible elimination products. To understand this, we need to learn something called Zaitsev's rule. So let's get a closer look at that now.
Let's say we have this starting material here, and we react with a strong base, such that E2 can occur. Let's identify all of the beta protons that will be available for elimination. Well, if we were to draw out the chair conformation for this molecule, we would find that this proton is available, and since there are two protons on this other carbon, we know that one of those will be available. Extraction of these protons by the base would lead to two different products. So let's show the pathway to those two products now. If the base grabs this proton, these electrons will form the pi bond here, which will kick off the leaving group, and we will get this product, where the methyl group has flattened out since this is now an sp2 center. If the base grabs this proton, the pi bond will form here instead, again kicking off the leaving group, and the methyl group will remain as it is. These are structurally different products, and we will refer to them with specific names. This first one is the Zaitsev product, and the second one is the Hofmann product. These are relative terms that are referring to the degree of substitution on the alkene product, and it is the case that the Zaitsev product is the more substituted alkene of the two, and the Hofmann is the less substituted alkene of the two. When we talk about the degree of substitution on the alkene, we are talking about the number of alkyl groups that are projecting from the two carbons participating in the double bond. The Zaitsev product is tri-substituted because of these three alkyl groups. The Hofmann product is di-substituted because of these two alkyl groups. So that is all there is to it in terms of assigning this relative terminology. Now, what we also have to understand is that the more substituted an alkene is, the more stable it is. This is for reasons similar to the way that carbocations are stabilized by neighboring alkyl groups via hyperconjugation. So tetrasubstituted alkenes are most stable, followed by tri-substituted, then trans-disubstituted, then cis-disubstituted, then monosubstituted, then unsubstituted. So remember, Zaitsev and Hoffmann are relative terms, and whichever of the two is more substituted is the Zaitsev product. Now we must discuss the tendency of a starting material to proceed towards one product versus another. Given the fact that the Zaitsev product is more stable, it is thermodynamically favored, and this gives us Zaitsev's rule, which says that base-induced elimination reactions generally give the more stable, more substituted alkene product, as it is the lower energy product. So given an unhindered strong base like hydroxide, this is the way it will go. However, this will not always be the case, as if we have a sterically hindered strong base, like tert butoxide, it will have a difficult time approaching this more hindered side of the molecule. The presence of this methyl group, which is the reason the Zaitsev product is more stable, is also offering more steric repulsion towards any base that approaches. And it is the case that with a very hindered base, this discrepancy will be enough to make reacting on this side quite difficult. Instead, the activation energy associated with reacting with this proton on the less hindered side will be much lower, so it is more likely to proceed via this pathway to give the Hofmann product. So to summarize, when we are confident that an elimination reaction is occurring, if there are multiple possible elimination products, it is the steric interaction of the base that will guide us. If sterically unhindered, we will get the more substituted and more thermodynamically favorable Zaitsev product, according to Zaitsev's rule. But if sterically hindered, we may get the less substituted and less thermodynamically favored Hofmann product.
With that, we have a better understanding of the types of products that are possible in an elimination reaction, and the preference of one over another according to Zaitsev's rule. Professor Dave for Chegg. See you next time.